Today we're going to go over Law of Exponents. As you can see, we have few, right? Make sure we remember any number to the first exponent is that number itself. Any numbers to zero exponent will be equals to 1. Negative exponents means you wanted to reciprocal your base. So for example, if you had a 4 to the negative first exponents, getting rid of the negative, you will flip the base. So instead of 4, which is in the numerator, it will become 1 over 4. 4 become denominator. If we have same base multiplications with different exponents, that will be the same as if you're adding the exponents. When you're dividing the same base with different exponents, you can combine the exponent by subtracting. If we have a double exponents on top of exponents, that will be the same as multiplying the exponents. Only times that you can distribute exponent is when you have multiplications and divisions. So if x times y to the nth exponents, then we can distribute n's exponents. Same thing with divisions. But don't forget, we cannot do that when we have additions and subtractions. So this is a law, so make sure only multiplication and division you can distribute exponents. This is similar to the one right here, negative exponents. So if you have negative n's exponents, you flip the base in order to get rid of that negative number, negative signs. Another one that we will probably go over is when we have fraction exponents. So x to the m over n's exponents, the numerator power become a power, denominator become your index of the radical. So if we have a 2 over 3, 2 will be your power, 3 will be cube root. Again, we will talk about a little more on the exponent in later sections, but this is very basic ones that we're going to go over. So let's see if we can do some of the examples, right? We have 2 squared times 2 to the 4th. So same base, different exponent of multiplication is same as if we add the exponents, right? So this is going to be equals to 2 to the 6 exponents. This one will be same base with different exponent multiplication. So same as we are adding 2 plus 3 will be 5th exponents. If you wanted to go any further using that exponents, you can use the calculator or you do the multiplications and you will get 64 for that one. So this one you have 5 negative, so your solution will be negative. When you multiply 5 times, you get 243. And this one right here, we do not have a grouping. So let me combine the exponent first by adding. So we'll give you 5, but that 5th exponent is going to be only apply 3, not the negative. So that will become negative 243. Same thing. Even if it's not the number variable, it will be the same thing. Same base, multiplications, then add the exponents. So it will be 5 plus 3 will be x to the 8 exponents. Let's do a few more. What about this one? This have double exponents, and we mentioned double exponents. You can multiply it, so it will be 3 times 2. That gives you negative 2 to 6 exponents. That is 64. positive because you're going to have 6 negative, right? Even number negative multiplication become positive. This one, double exponents, we mentioned that same as multiplying, so it will be 2 times 5, which is going to be 10. What about this one? You have a double exponents, so you're going to multiply 2 times 4 and times 7 cubed. Multiplication with same base. Different exponents means you're going to add them, so it will be 8 plus 3 will be 11. This is the one that you can distribute because it's multiplications, 2 times x, right? So you can distribute 3 to the 2 and 3 to the x, which will give you 8x cubed. This is another one you can do the distributions. Why? Because it's all multiplications. You can see that 2 times x cubed times y, so you can distribute 4 to 2, 4 to x, and 4 to y. And when you're distributing 4 to 2, you get 2 to the 4th exponents. X cubed times 4 will be 12. Y, 1 times 4 will be 4. Which 2 to the 4th exponent is 16. And rest of them stay same, right? This one is another multiplication, so you're going to distribute. And one mistake I always see that you forget to distribute exponent into the negative signs also. So make sure, because you have a parenthesis, right? Because you have parenthesis, distribute into the negative 4 and variable y. You're going to distribute 3 times. So negative, 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 multiplying, it will be still negative 4 to cube and y to cube, which gives you negative 64y cubed. This one, you're going to distribute 4 to 2, 4 to x, 4 to y. So it will be 3 times 4. And then this one have first exponent, which is going to not make any change, right? Now we can combine the like terms, and let's try to simplify it. So 2 to the 4th exponent. 2 to the 4th exponents, you can simplify it by multiplications, and you know that will give you 16, because 2 times 2 times 2 times 2, right? Multiply 2 4 times. And then this is the like term, like base, right? Multiplication, so add the exponents. Gives you 6 exponents. And this too is going to be like base. So it will be 12 plus 1 will be 13. Example 2, we're still using law of exponents. So let's look. When we have a same base divisions, we do subtractions. Depends on where we wanted to bring it up or down, right? So I wanted to bring it up since the numerator exponent is larger. So then I will get 3 to the 7 exponents minus 5. Whichever it's moving, you're going to subtract. Gives you 3 squared, which is going to be 9. This one will be the same thing because your exponent on the numerator is bigger than denominator. You're going to bring it up. So then you get negative 2 to the 8 exponents minus 5. Give you negative 2 to the 3rd exponents. That will be negative 8. Right? Again, bring it up by subtracting denominator exponents. even it's a variable, right? It will give you x to the fifth exponent. This one, I wanted to bring down. Why bring down? Because my exponent on denominator is bigger than the numerator. 8 is bigger than 5. So if I bring it down, I will have 1 over negative 3 to the 8 exponent minus 5 gives you 1 over negative 3 to the cube. That gives you 1 over negative 27. Same thing when if it's variable, right? Denominator exponent bigger, bring it to denominator. 5 minus 2 give you 1 over x cubed. We went over the distributing exponent when it's multiplication. We also distribute exponent when it's divisions, right? So this can be 3 to the 9 exponents over 5 to the 9 exponents. And this one will be x to the 4 exponents over 3 to the 4th exponent. This is not only distributing numerator denominator, but you also have a multiplication. So distribute into all the factor, right? So we'll give you 3 to the 5th exponent, x to the 5th exponent over 2 to the 5th exponent, y to the 5th exponent. 3 to the 5th exponent is 243, x to the 5th exponent on the numerator. 2 to the 5th exponent is 32, y to the 5th exponent. The next example, we wanted to talk about having a 0 exponents, right? Remember, well, just follow the order. So right now I see the fractions with the same base, so I wanted to combine it. If we bring it to the numerator, it will be 3rd exponents minus 3, so that gives you 0. Any number to the 0 exponent is equals to 1. The next one, any numbers to 0 exponent is equals to 1. Even this one, any numbers to the 0 exponent is equals to 1. But the next one is not going to be, right? Because if without the parenthesis, 0 exponent only apply to the number, not the sign. So then sign will stay same. 3 cubed is equals to 1. This one is going to be negative 3 times y to the 0 exponent is 1, which give you negative 3. The next one, we have negative 2 to the 0 exponent. Because the parenthesis, the whole thing become 1. But then you have another multiplications. Negative 2 cubed is going to be negative 8. So that gives you negative 8. Let's look at the next one. We're going to apply everything we had before. So I see all the multiplications and divisions. So we can distribute exponents. So that gives you 2 to the 4th exponents. 0 times 4 will be 0. 3 to the 4th exponents. Y to the 5 times 4 is 20. If you wanted to simplify further, because I know what's 2 to the 4 exponent is going to be. And same thing with 3 to the 4th exponent. I should be able to write it this way. This 2 is the same thing. It's just doing the multiplication one more step. We did not go over negative exponents and fraction exponents, and that's something we will go over it in different sections.